A ver, check my speaker. All right, let me headset. A headset. Hola, hola. Hello, guys. How have you been? I hope you're doing well.
Hi.
Hi. Da, 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 da. All right, guys. Today we're going to learn another situation. Yesterday, we learned how to predict the quantity of people they're going to accept or they're going to hate some kind of product or some kind of television network program, something like that, providing the predictions of the people who's going to differentiate between a sample and the random survey. Now, today we're going to apply one of the principles of counting in the probability. In this principle of counting, when we're talking about the permutations. What does that mean, that word? Because it sounds kind of weird. Where the permutation, my dear students, is the arrangement of the objects, which is order is important. It's simple. If you really want to count how many objects do you have in your room and you're going to arrange by the order, this is a permutation. For example, in one singular box, you're going to, for example, put science books. You're going to have the science books, your homework science, the science, how to say that, worksheet, science, pictures, or something like that. So because you're going to have a box putting together the quantity materials that will be useful for the science class, that will be a permutation because you're going to have an arrangement of objects that will be useful for one singular subject. Same happens with math. In one other box, you're going to uh, keep, for actually, the study guides, your math book. Actually, if you check your YouTube, that YouTube channel, you're going to see the quantity of videos we're going to arrangement by order since the first day until the last day in the math videos. So in that situation is what we're talking about the permutation. So basically order the quantity of things or the quantity of materials that will be useful to obtain one singular result. All right. That's why the order is so important. For example, you have three letters, A, B, and C, right? And if you want to apply the total arrangement, you can provide for these three letters, all right? As soon as you can see the order, you can come mix. These letters could be ABC, ACB, BAC, BCA, CAB, and CBA. Actually, the total number of the arrangements when we have to, or we can apply using three letters, that will be six. That's why we have six permutations, six different orders. We can write the three letters, ABC, ACB, BAC, BCA, CAB, and CBA. Fortunately, fortunately, there's a math technicians or a math principle of counting that we can useful at the moment. We're going to obtain what will be the number of arrangements we're going to use in one singular situation. Could be books, materials, letters, shirts, socks, I don't know, pencil, colors, something like that. In that principle of counting, that will be useful for the permutations. And if you read carefully what the theoretical part says, every time that you use a letter or pencil, something like that, and create the permutation, the number of the remaining letters can be chosen decrease one. For example, if you started from 5 objects, you can multiply the next one by 4, the next one by 3, the next one by 2, and the last one by 1, and the product between them, that will be the quantity of permutations. So say happen if we have the three letters ABC, if we are applying the principle of counting, remember ABC, we're starting from three letters, right? After that, we're going to multiply by 2 because we're decreasing 1. And the last one, decreasing 1 because we're getting 1 unit. 3 times 2 times 1, the answer will be 6, right? So this operation can be written like the number, obviously the maximum number in this case is the number 3. This exclamation sign, that means 3 factorial is the recursive decreasing product of the numbers. That's the meaning of this expression, 3 factorial, because we're starting from 3, after by 2, after by 1, and that will be 6. Okay, 3 exclamation symbol can be read like a factorial. And the value of 0 factorial, because you're going to ask, Mr. What happened if we're going to use the number 0? By definition, because it's accounting principles, every time that we're going to count something, it doesn't matter. We're talking about letters, shoes, eraser, pencils, whatever you want. We're going to start from the number 1, right? Nobody counts like a 0, 1, 2, 3, 4. No, we're starting from 1. For that reason, the value of 0 factorial by definition will be 1. Examples. If I ask you in the first example, what is the value of 7 factorial? 7 factorial, right? Number 7 and exclamation symbol. Well, it's simple. What are we going to do? We're going to start from the number 7, multiplying by the next one. 7 minus 1 will be 6, right? Another one will be 5. Another one will be 4. Another one will be 3. Another one, 2. And the last one will be 1. And this is going to be a product. Please multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. Use your calculator, please, and multiply all of these numbers. 7 times 6 times 5 times 4. 5,000. Multiply 5,000. 40. Okay, 5,040. And this is going to be the answer because we have the value from 7 factorial. Another example. What is the value of 5 factorial? Okay, 5 factorial, what does that mean? We're going to start from the number 5, right? We're going to start from 5. The next one will be 4. The another one will be 3. The another one will be 2. And the last one will be 1. Okay, would you like to tell me? 120. Okay, 120. 120. Understood? All right, this is the definition of the principle of counting. This is the starting, but actually this is the 56% of the process. Es el 56% del proceso. Espérense, ya vamos a llegar, cálmense. Cálmense. Si entendieron esto, casi ya le entendieron a todo. En casa, ¿estamos claros cuál es la definición de factorial? ¿Sí o no? Hola, confirmen en casa, ¿entendieron?
Yes, Mr.
All right then. So, we have another example. Okay, we have another example. The example number 3. A copy over here. You have, guys, you have 4 posters, 4 posters, 4 posters to hand in your room. To hand in your room. Period. You want to put one poster. You want to put one poster on each wall. On each wall. Okay. The question is, period. How many how many ways how many ways can you arrange how many ways can you arrange the posters? This is a little application, right? This is a little work problem. What are we going to do? You have 4 posters to hand in your room. You want to put one poster on each wall. How many ways you can arrange the posters? What are we going to do? 4 factorial, right? Excellent. Another way of saying is 4 factorial. What this is what Pamela says. Okay, remember, in simple merely words, you're asking for what will be the value for of 4 factorial. In simple merely words, 4 times 3 times 2 times 1. Okay, and the answer will be 24, right? How many ways can 24 ways? 24 ways you can arrange the posters, right? This is so easy as long as you can see the concept of the factorial, right? Because it's the principle of counting. What is the difference between permutation and combination? Well, we're going to study a combination a few lessons later, but the difference between a permutation combination is the permutation, the order matters. The order matters. In the combination, the order doesn't matter because, for example, if you really want to combine one situation, for example, in one box, remember, we established the example when we said we're going to have the math books. We have the study guides of the math books, the worksheets of the math books, the videos of math books. This is a permutation because in one singular box, you are arranged, you have the arrangement or of the math materials. But what happens if that box, you're using the science books, the science worksheets, the science videos, you're combining because there's no have a specific order because we're mixing with math and science, right? So that will be a difference between combination and permutation. But meanwhile, this is permutation. Do you have some questions? No questions. All right. So now let's going to start with the real formula for permutation. Cálmense. Imagínese, ya está llorando y ni siquiera ha comenzado con la fórmula de las. Imagínense. Vamos a ver. Aquí está. Vamos a poner aquí. Permutations. Permutations, permutations, permutations. This is the principle of the permutations. Let me write the concept. The number of permutations, the number of permutations, the number of permutations of n objects taking R taken, taken are objects or are at the time of the time can be greater, can be greater, can be greater as in PR, in PR, where, chon, 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 chon. This is the formula. Pay attention.
Mister,
Yep. Sí, André. Oh,
Mister me escucha.
no escucha. Hola, hola, hola. A ver, a ver, a ver. Headset. Hola. ¿Me escuchan los demás?
Mister,
Hola, hola. ¿Y ahora? ¿Me escuchan ahora? ¿Me escuchan ahora? Confirmen. Clase.
Sí,
Yes.
pero creo que él es el que está
Yes,
diciendo
mister.
¿escucha o no?
Ah, bueno.
Yo,
I
yo no
know you
sé
can
si me
hear me, guys.
escucha, pero si me habla no lo está usted, yo no lo escucho.
Mm. Sí, seguro, revisa bien, Andrés. Y porque aquí yo vieron
Si
micrófonos,
me
el micrófono
escucha
ahí.
después, escríbame en el chat, por
Pues yo le escucho bien a usted.
favor.
Yeah, I know.
Una letra.
Yeah, you can hear me. Sí, yo lo escucho
No
perfectamente,
escucho
Andrés.
nada.
Yo lo escucho, fuerte y claro. Claro que sí. So, once again, the number of permutation of n objects taking R objects at the time can be written as P and PR, where and PR, this is the formula. And PR will be equal to n factorial over n minus R factorial.
Mister,
This is the formula from the factorial. Yes, Andre? What can I do for you?
¿me escuchó o no?
Sí, claro que sí.
Ah, es que yo no lo escuchaba a usted.
Ajá.
Mm,
¿Y ahora
ok,
usted me
ya
escucha?
Ahora sí, sí, es que era, creo que era yo porque me volví a salir y entrar y ahora sí.
Sí, que a veces pasan con Zoom. All right. And remember, guys, and the letter N always, always, always will be greater than R. This is the golden rule. Okay. So let's going to apply that one single example with the permutations we were talking about. Before to apply word problems, because actually we really need to know how to use this formula. The example number 4. The example number 4 said, find the number of permutations. Find the number of permutations of letter A. We have 8 pi, sorry, AP3, AP3, and letter B, we have 6P2, 6P2, okay? This is going to be the example number 4. How are we going to do that situation? All right. Okay, relax. Ok, está bien, ya le bajo. Ok, ok, ok. Les cuento, muchachos, para que no se pierdan el chambre allá en casa. Aquí un estudiante me dijo, ¡párale! Va muy rápido. Vamos a bajar.
Sí, mister, espera un ratito.
Bueno, es que ustedes no me dicen nada, por eso yo sigo. Bueno, hoy sí ya me dijeron, hoy sí ya le bajo la revolución, pero pues no me dicen nada, ¿cómo lo sé? Que por eso tienen que hablar. Así como me dijo cierta alumna aquí, ¡párale! Me dice. Así, no digo ni, permítame, viste, por favor, ¿cuál? De un solo, espérate. Sí. Más claro no puede ver. Bótelo en la basura, por favor. Bótelo. All right, let me know when you're ready. Bueno, let me know when you're ready. Eight. All right, then. In the first problem, A, B, 3. All right, we're going to calculate A, B, 3. Remember, we're going to apply this formula. Always N will be greater than R as soon as you can see. So we're going to apply A factorial over parentheses 8 minus 3 factorial. In simple merely words, AP3 will be equal to A factorial divided by A minus 3, 5, right? 5 factorial. Now what we're going to do, let's going to apply the concept of the factorial. A factorial, remember, we're going to start from 8, right? Will be 8, 7, 6, 5, 4, 3, 2, and 1. Right? Because this is the concept of 8 factorial. The number 3 is the R value. We're going to take 3 objects of 8. And that's why A minus 3, we're going to find 5. And 5 factorial, we're going to start from 5, 4, 3, 2, and 1. Sorry. And if you see this multiplication since 5 up to 1 can be canceled with this one because we have a product, right? Yes or no? 5, 4, 3, 2, 1 can be canceled with 5, 4, 3, 2, 1. And the missing will be 8 times 7 times 6. 8 times 7 times 6. So the answer will be we can cancel. Yes. Every time if we have the answer, the same in the division, you can cancel the same numbers, okay? And the answer will be 8 times 7 times 6 will be 336, right? 336, 336. And that's it. Not complicated thing. Hoy anda agresiva Pamela, ya veo con todo el mundo. ¿Entendieron en casa? ¿Entendieron? Okay, understood, guys?
Yes.
Excellent. Now the letter B. The letter B. 6, 6, P2. Same thing. 6 factorial over 6 minus 2 factorial. Again, 6P2 equals 6 factorial over 4 factorial, right? 6 minus 2. Well, continue. Slowly. La misma cosa. 6 factorial, lo mismito, solo que con otro número, es la misma cosa. ¿Cómo así? La respuesta va diferente porque son diferentes números, pero el proceso es lo mismo. ¿Perdone? No, obvio, tiene que ser diferente porque no es lo mismo 6 entre 4. Y que lo que pasa es que aquí era 6, 2. 6 le quita 2 es 4. O sea, el mismo proceso, pero la respuesta te va a dar diferente. Diga. Sí, sí, sí. Ahora, sí hay que cancelar. Sí, hija. Ahora, permita que yo, Jessica, emocionada ya. ¿Qué pasó, Jessica? Ajá, entonces solo te queda 30 sería la respuesta, correcto. 30 les va a dar la respuesta, pero lo vamos a hacer despacio. Mire, 6 factorial es 6, 5, 4, 3, 2, 1. Y aquí, ¿cuántos factoriales? 4, 3, 2 y 1. Mire, ¿qué va a pasar? 4, 3, 2, 1 se va con 4, 3, 2, 1. Y me queda 6 por 5. Y eso es 30. Y ahí está. Eso es todo. Bueno, entonces, mis estimados, lo vamos a dejar hasta aquí por el día de hoy. El día de mañana vamos a hacer word problems using permutation. And after that, we're going to introduce the lesson of the combination. All right? Yeah, go right ahead. Okay, guys. Thank you. Okay, so thank you so much for your attendance. Have a great, wonderful day. Take care of yourself, guys. See you tomorrow.
Bye, Mr.
Bye bye. So long. Take care of yourself.